Hey, my wonderful Bronx Arts team. How are you? Hopefully, everyone's doing well. This is the recording for Thursday, April 2nd. It's continuing with our lesson 13, reading 1. What happens to mass during a chemical reaction in an open system? So, yesterday's lesson, or Tuesday's lesson, ended with the bicycle. And now we're going to continue the reading, which you see is right under. Both the reaction that causes the magnesium to burn and the reaction that causes a bike to rust have reactants that are invisible to the eye, since they both need oxygen as a reactant. And obviously, oxygen is invisible to the eye. That oxygen needs to come from somewhere. In both cases, it comes from the air. Scientists call this an open system. You might guess that an open system is when something is allowed to be added or is allowed to escape. In class, we haven't done this part. You observe chemical reactants occurring in both open and closed systems. We actually have. One of the closed systems that we did was when we did the Ziploc bag. And remember, we before we allowed the liquid to touch the substance, we made sure that bag was completely closed. We made sure all the air was out. That is considered a closed system. And that's something they're going to talk about in this particular lesson. So just think about that. And then the open system, you guys know, is when you allow air in, or things can either come in or escape. So that's the difference between your open system and your closed system. You might guess that an open system, like we said, is when something is allowed to be added or is allowed to escape. The magnesium burning is an example of an open system. Remember, it wasn't closed in anything. It allowed that air or the water to be able to get in and intensify the burning. When you did the plastic bag experiment using baking soda and road salt, you sealed the bag shut before you mixed the ingredients. By doing this, you created what scientists called a closed system. A closed system is when nothing is added or allowed to escape from the system. If we created a closed system for the burning of magnesium, the reaction would stop either when the oxygen was used up or when the magnesium was fully burnt. Again, because if it's a closed system, you have a limited amount of oxygen. All right, so closed systems mean that you are not allowing anything else in, and it's completely closed. It's just whatever substances that are present. How does paint on cars and bicycles help prevent rusting? Think about that question, because that's going to be in your Google Docs. So just think about that. How can paint help to prevent rusting? Remember what causes rusting. Think about that from yesterday's lesson. And think how paint would help to prevent rusting. All right. So now let's think back to the investigation with the reactions you mixed in the plastic bag. When you combined the two reactants, you observed that the substances bubbled. A precipitate formed. Hopefully, you guys remember that word precipitate. That is when a solid starts to form and it kind of settles at the bottom. And a temperature change occurred. If you remember, a lot of you who did it correctly, when you had that Ziploc bag in your hand, you noticed it started to get warm. First, imagine that you had measured the mass of the plastic bag of reactants before you mixed the ingredients. Second, imagine that you tipped over the container of water and measured the plastic bag again. So here is mass of the bag plus the reactants before mixing. And over here is mass of the bag and reactants after mixing. Imagining these two measurements of mass will help you answer the following question. In the plastic bag experiment, do you think the mass of the products after the chemical reaction would be greater than less than, or the same as the mass of the reactants before the chemical reaction. Give your reasons for your answer. Think about what we've learned about mass. You already know what chemical reactions are, but focus on that definition that you know of mass and answer this question. All right, and if you have any questions, I will see you in our Google Meet. Have a wonderful day, Professor.